and we'll keep drifting, floating together through the mysteries, 100 stars mysteries, looping softly, endlessly through the night. Tonight we'll drift through the hidden colors inside dying red giant stars, stars that vanish without exploding. Ancient maps written in starlight. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing. Thump, thump, matching the rhythm of space itself. Shoulders melting down, jaw releasing. Each breath pulling you deeper, deeper, into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too. But only if your eyes are still open. Otherwise, just drift. Now, let's drift into stars. In the beginning, there is only darkness and cold, vast clouds of gas hanging in the void, hydrogen mostly, with traces of helium, drifting so slowly for millions of years. These are the stellar nurseries as the nebula, where gravity whispers its first invitation, pulling, gathering, drawing molecules closer, thump, thump, like your heartbeat now, steady, patient, inevitable. Inside the Orion Nebula, just below the Hunter's Belt, if you could drift there tonight, you would see pillars of gas collapsing, condensing, becoming denser, heavier. The cloud contracts, and as it does, something beautiful happens. It warms. Friction between particles, releasing energy, soft heat, blooming in the cosmic dark. This is how stars begin, not with explosion, but with gentle, relentless, falling inward. Let your eyes grow heavy now, heavier, as we watch a protostar form. This baby star, still wrapped in its cocoon of dust, cannot be seen in visible light, but it glows, infrared warmth, pulsing, growing, fed by the cloud around it. For 100,000 years, perhaps 1,000,000, it gathers mass, pulling more gas onto itself, spinning faster, flattening into a disk. And then, when the core grows dense enough, hot enough, 4 million degrees, something ignites. Hydrogen atoms, moving so fast they overcome their natural repulsion. They fuse, becoming helium, releasing light, pure radiant energy. This is nuclear fusion, the heartbeat of every star. Thump, thump, and the protostar becomes a star. Our galaxy, the Milky Way, holds stellar nurseries like flowers in a garden. The Eagle Nebula, with its famous pillars of creation, so tall they would stretch from the sun to the nearest star, and inside each pillar, dozens of stars forming right now, even as you breathe, in and out, slowly, deeply. The Carina Nebula, birthplace of some of the most massive stars ever found, glowing pink and gold, if you could see it, stretching across 300 light years, where baby stars blow bubbles in the gas, sculpting, creating endless cycles of birth, just like your breath, in, out, creating, releasing. A star's life, how long it burns, depends entirely on its mass. Heavier stars burn faster, living only millions of years, while the smallest red dwarf stars, sipping their fuel so carefully, can shine for trillions of years, longer than the current age of the universe. They will outlive everything, burning dim and cool, patient, eternal. Red dwarfs, the most common stars, making up 3/4 of all stars in existence, though not one is visible to your naked eye. Too faint, too small, glowing deep crimson. Surface temperatures only 3,000 degrees, compared to our sun's 6,000. They conserve, they endure, they wait. Our sun is a yellow dwarf, middle-aged, stable, burning through 50 million years of hydrogen every second. Yet it has fuel enough for 5 billion more years. It sits in perfect balance, radiation pressure pushing outward, gravity pulling inward, equilibrium, like your body now, perfectly balanced between waking and sleep, drifting, drifting. Blue giant stars, the brilliant ones, burning fierce and fast, surface temperatures 30,000 degrees or more. They are profligate, wasteful, beautiful, living perhaps only 10 million years, but outshining our sun by thousands of times. Rigel in Orion, Spitta in Virgo, jewels in the night, burning blue-white, soon to die. Let your jaw soften, throat releasing, as we drift toward the red giants. When a star like our sun exhausts the hydrogen in its core, fusion stops, the core contracts, heavier, heavier, heating up, and the outer layers, they expand, swelling outward, cooling as they stretch, turning red. A red giant can swell to enormous size. Betelgeuse, in Orion's shoulder, has expanded so large it would swallow Mercury, Venus, Earth, and Mars if placed where our sun sits. Yet its surface, cool enough, only 3,000 degrees, glowing the colour of embers, fading, softening, like your thoughts now, dispersing, dissolving. Inside a red giant's core, where when it grows hot enough, 100 million degrees, helium begins to fuse, creating carbon and oxygen. The atoms that make your body were forged inside dying stars like these. You are made of star stuff, literally, chemically. Every breath you take contains oxygen from ancient stars. Every beat of your heart, thump, thump, pumps iron created in stellar cores, supergiant stars, even larger, Antares glowing red, V Canis Majoris, so enormous that light takes 8 hours to travel across its diameter. If you could drift near one, you would see storms, convection cells larger than our entire solar system, churning, rising, falling, like the slow rise and fall of your chest, breathing deeply, slowly, and beyond even these, the hypergiants, the most massive, most luminous, most unstable stars known, are 136A1 in the Large Magellanic Cloud, weighing as much as 300 suns, shining with the light of millions of suns. Its stellar wind, gas streaming off its surface, creates a bubble light years across. It cannot last. Stars this massive burn for only a few million years before they end. Stars are grouped by their chemistry. Population I stars, like our sun, metal-rich, formed recently from gas already enriched by previous stellar generations. They orbit in the galactic disk, young, bright, containing iron, carbon, oxygen, all the heavy elements. Population 2 stars, older, found in globular clusters in the galactic halo, metal poor, formed when the universe was younger. Their light reveals their age, spectral lines showing mostly hydrogen and helium, with only traces of heavier elements. They drift in elliptical orbits, ancient, witnesses to cosmic history. And population 3 stars, never seen, only theorized, the very first stars, born from pure hydrogen and helium, no metals at all, massive beyond imagining, burning bright and dying fast, seeding the universe with the first heavy elements. They exist only in our mathematics, in our dreams, like the visions forming now behind your closed eyelids. The Hertzsprung-Russell diagram maps stars by temperature and brightness and reveals a pattern. Most stars fall along a diagonal band. The main sequence is where stars spend most of their lives, fusing hydrogen, stable, balanced. Our sun rests here, in the middle, average, unremarkable, perfect. Temperature determines color. The hottest stars, blue and white, 40,000 degrees or more. Cooler stars yellow, then orange, then red. The coolest barely 3,000 degrees, but the color you see, looking up at night, is often false. Atmospheric turbulence bends the light, making stars twinkle, dance, shift through colors, a beautiful illusion, like dreams, neither true nor false, simply shimmering. The true color of most stars is actually white. Our sun appears yellow only because Earth's atmosphere scatters blue light. In space, it would glow, pure white, if you could see Sirius without air between, not the twinkling blue-white you know, but steady, colorless, perfect. Many stars aren't alone. Binary systems, 2 stars orbiting their common center of mass, dancing, eternal partners. More than half of all stars have companions. They orbit, sometimes close enough to touch, exchanging atmosphere, sharing mass, influencing each other's evolution. Triple star systems, 3 stars bound together. Alpha Centauri, our nearest stellar neighbor, is actually 3 stars. 2 sun-like stars orbiting close, and a distant red dwarf, Proxima, circling them both. A family held by gravity, turning slowly through space. When binary stars orbit close, very close, tidal forces lock them, faces always toward each other, and sometimes one star feeds on the other. Mass transfers through streams of gas, flowing from the larger star onto its companion. The donor shrinks, the receiver grows, a stellar vampire, patient, persistent, inevitable. Eclipsing binaries cross in front of each other from our view. The light dims, brightens, dims again, regular as clockwork. Algol, the demon star, in Perseus, eclipses every 3 days. Ancient astronomers noticed and feared its changing brightness. They called it evil, but it's only geometry. Two stars passing, blocking light, creating rhythm, like your heartbeat. Thump, thump, steady, reliable. Some stars vary in brightness intrinsically, pulsating, swelling and shrinking, Cepheid variables, massive yellow giants that expand, contract, expand again, days or weeks per cycle. The brighter they are, the slower they pulse. This relationship, discovered by Henrietta Leavitt, turned Cepheids into standard candles, measuring cosmic distances, their rhythm, written in light, telling us how far, how old, how vast are our Lyrae stars, smaller pulsators found in globular clusters. They pulse faster every few hours, and all have roughly the same brightness, making them another measuring stick, another way to read distance in the dark. Let your breathing match their rhythm now. In, out, regular, calming, perfect. Stars spin, some slowly like our sun, one rotation every 25 days, others incredibly fast. Vifts 102 spins once per day, its equator moving at 2 million kilometers per hour. So fast, it's nearly ablate, flattened by centrifugal force, stretched, distorted, like taffy, like your thoughts now, stretching, thinning, dissolving into sleep. Stellar magnetic fields twist and writhe, creating star spots, dark patches where magnetic field lines pierce the surface, cooler than surrounding areas, like sunspots on our sun. But on some stars, enormous, covering half the visible surface, the magnetic field loops, arches, sometimes snaps, releasing energy. Stellar flares, a stellar flare, magnetic reconnection, sudden and violent, releases as much energy as 1 billion nuclear bombs. Plasma erupts, particles stream outward. If you were close, the radiation would, but you're not close. You're here, safe, warm, sinking deeper into comfort, heavier, heavier. Coronal mass ejections from stars blast billions of tons of plasma into space, creating stellar winds that shape the environment around them. Our sun's wind blows constantly, filling the solar system with charged particle, extending far past Pluto into the darkness beyond. A bubble, protecting, containing, like blankets around you now. Metallicity. Astronomers call anything heavier than helium a metal, iron, carbon, oxygen, nitrogen. All metals in this language. A star's metallicity reveals its history. High metallicity means birth from enriched gas, recycled from previous stars. Low metallicity, ancient birth, pristine material. Each star's spectrum, its fingerprint, tells the story. Stellar spectroscopy, reading starlight. When you split starlight through a prism, it shows dark lines, absorption lines, where elements in the star's atmosphere have absorbed specific wavelengths. Every element has its own pattern, its own signature. Hydrogen, helium, iron, calcium, all revealed. We can read a star's composition, temperature, motion, all from light, traveling for years, centuries to reach us. To measure how far away a star is, we use parallax. As Earth orbits the Sun, nearby stars appear to shift position against the distant background. The closer the star, the larger the shift. Simple geometry, elegant, reliable for stars within a few thousand light years. Beyond that, the shift becomes too small, and we need other methods. Standard candles, stars of known brightness, Cepheids, R. Lyrae, type Ia supernovae. We measure how bright they appear, compare to how bright they should be, and calculate distance. Like knowing a light bulb's wattage, then judging distance by how dim it looks. Simple, profound. The foundation of cosmic distance measurement. Stars move through space, not fixed. Despite ancient names, proper motion, sliding across the sky, too slow for eyes to notice in a lifetime. But telescopes measure it, mapping trajectories, predicting futures. Most stars orbit the galactic center, orderly, predictable, taking 200 million years to complete one orbit. But some stars move differently. Runaway stars, ejected from binary systems when their companion exploded, or flung out by gravitational interactions in dense star clusters. They race through space, faster than their neighbors, Zeta Ophiuchi, creating a bow shock, like a boat through water as it plows through interstellar gas. Hypervelocity stars move faster still, 1,000 kilometers per second or more, fast enough to escape the galaxy entirely. We think they were accelerated by close encounters with the supermassive black hole at the galactic center, flung outward, exiled, doomed to drift alone through intergalactic space, forever. All stars generate stellar winds, streams of particles flowing outward. Our sun's wind carries 1 million tons of material into space every second. It sounds like a lot, but over the sun's lifetime, it will lose less than 1% of its mass this way. Gentle, persistent, like erosion, wearing stone, grain by grain. Massive star, blue giants, supergiants have much stronger winds. Wolf-Rayet stars, among the hottest, blow off their outer layers completely, revealing bare helium cores, glowing blue-white, surrounded by nebulae formed from their own lost mass. They're dying, even as they shine, preparing for the end. Old red giants also lose mass more gently, puffing off their outer atmosphere. These shells of gas expand, cool, and form planetary nebulae, nothing to do with planets. The name comes from early telescopes, where these round glowing clouds looked planet-like. But they're stellar death shrouds, beautiful, ephemeral, lasting only tens of thousands of years before, dispersing, fading, returning to the interstellar medium. At the center of a planetary nebula, the star's core remains, small, dense, no longer fusing, a white dwarf, Earth-sized but containing half a sun's mass, supported not by fusion, but by electron degeneracy pressure, a quantum mechanical effect. Electrons cannot occupy the same space, cannot be compressed beyond a certain point. This pressure holds the white dwarf stable, cooling for billions of years. White dwarfs glow from leftover heat, starting at 100,000 degrees or more, but with no internal fire. They gradually cool, fading through white, yellow, red, eventually, after trillions of years, becoming black dwarfs, dark, cold, crystallized carbon and oxygen, stellar diamonds, invisible, eternal. But the universe isn't old enough yet for any black dwarf to exist. They remain theoretical, future ghosts. If a star is massive enough, 8 times the sun or more, its end is different. The core, after fusing hydrogen, helium, carbon, neon, oxygen, eventually creates iron, and iron cannot fuse. It takes energy rather than releasing it. So when the core turns to iron, fusion stops completely, instantly, without radiation pressure to hold it up. The core collapses. In less than a second, matter falls inward, faster, faster, until neutron degeneracy pressure stops it. A core the size of Earth, compressed to the size of a city, 20 kilometers across. 1 teaspoon would weigh 1 billion tons. A neutron star, spinning, radiating, incredibly dense, supported by the refusal of neutrons to overlap, quantum pressure, holding back infinity. Some neutron stars beam radio waves from their magnetic poles. As they spin, these beams sweep across space like lighthouse beams, and when they point toward Earth, we detect pulses. Some pulse hundreds of times per second, millisecond pulses, spun up by stealing mass from a companion, timing so precise that pulses keep time better than atomic clocks. Thump, thump, thump. Universal metronomes, measuring infinity. Magnetas, neutron stars with the strongest magnetic fields in the universe. Quadrillion times stronger than Earth's field. The magnetic field. So intense it warps atoms, changes chemistry, would kill you 1,000 kilometers away. Sometimes, the magnetic field shifts, suddenly, cracking the neutron star's crust, a starquake, releasing energy in seconds, equal to what our sun emits in 250,000 years, a brief flash, gamma rays, announcing cosmic violence, the collapse that forms a neutron star, if the core is massive enough, doesn't stop. Even neutron degeneracy cannot hold, and the core keeps falling into darkness, becoming a black hole. But that's another journey for another night. Let your mind drift back now to the stars still shining. Not all massive stars explode. Failed supernovae happen when the core is too massive, 25 solar masses or more. The collapse bypasses the explosion stage. Matter falls directly into the forming black hole. The star simply vanishes, dimming, fading, gone, without fireworks, a quiet end to a giant life. Pair instability supernovae occur in the most massive stars, over 100 solar masses. In their cores, energy becomes so intense that photons spontaneously turn into particle-antiparticle pairs. This removes pressure and the star collapses, but rebounds violently. Thermonuclear explosion. So energetic the star is completely destroyed, leaving nothing, not even a remnant, just expanding debris and light, fading into memory. Stars create heavy elements through fusion. Hydrogen becomes helium. Helium becomes carbon and oxygen. Then neon, magnesium, silicon, each step requiring higher temperature, higher pressure, deeper in the core, until finally iron forms, the end of the line, the most stable nucleus. But elements heavier than iron, zinc, silver, gold, uranium, cannot form through fusion. They require supernovae. When a massive star explodes, the incredible heat and neutron flux allow rapid neutron capture, building heavy elements in seconds, the gold in wedding rings, the uranium in nuclear reactors, the silver in jewelry, all forged in dying stars, scattered, drifting, eventually gathering into new solar systems, new planets, new life. This is cosmic recycling. The gas and dust ejected by dying stars mixes with the interstellar medium, enriching it with heavy elements. Eventually, gravity gathers this enriched material, forming new nebulae, new stars, new planets. Each generation, slightly richer in metals, slightly more complex, the universe, learning, growing, creating through stellar death and rebirth, endlessly, like you're breathing now. In, out, in, out. Stars and galaxies evolve together. The first stars change the universe fundamentally, ending the cosmic dark ages. They formed from pure hydrogen and helium, burned bright, died fast, and seeded space with the first heavy elements, making possible everything that followed, including, eventually, you. The Dark Ages lasted hundreds of millions of years after the Big Bang. No stars yet, just neutral hydrogen gas, opaque to light, cooling, waiting. Then, gravity formed the first density fluctuations. Gas began collapsing, and the first stars ignited, massive, blue-hot, brief. Their ultraviolet radiation ionized the surrounding hydrogen, creating bubbles of transparency that grew, merged, until the entire universe became transparent again. The cosmic dawn. These first stars, population 3, likely weighed hundreds of solar masses. They lived fast, maybe only a few million years, and died as pair instability supernovae, completely destroying themselves, spreading their synthesized elements, carbon, oxygen, iron, into the pristine gas. No population 3 star has ever been observed. They're too distant, too ancient, existing only in the universe's first billion years. Globular clusters hold some of the oldest stars we can see. Population 2 stars, 10 to 12 billion years old. They orbit in the galactic halo, hundreds of clusters, each containing hundreds of thousands of stars, packed densely. In the cluster's core, stars pass within light hours of each other, close enough to interact, perturb orbits, occasionally collide, open clusters, younger, less tightly bound, the Pleiades, Hyades, Beehive, born from the same nebula, drifting apart over hundreds of millions of years, eventually dispersing completely, their member stars scattered, unrecognizable, lost among the field stars, like memories, fading, separating, dissolving into the general background of thought. Stars near the galactic center experience a different environment, the density there, millions of times higher than in the solar neighborhood. Stars packed close, the supermassive black hole, Sagittarius A, weighing 4 million solar masses, dominates. Stars orbit it, some in elliptical paths, swooping close, then retreating. S2 orbits once every 16 years, reaching speeds of 5,000 kilometers per second at closest approach, relativistic, time-dilated, stretched by gravity's grip. The largest known star, Stephenson 218, a red supergiant, possibly 2,000 times the Sun's diameter. Though measurements are uncertain, pulsating, unstable, shrouded in dust. If placed at the Sun's position, its surface would extend past the orbit of Saturn, unimaginably vast, yet doomed. Stars this large cannot last. Radiation pressure, stellar winds, they tear themselves apart. The smallest known stars, red dwarfs barely massive enough to sustain fusion, 8% of the Sun's mass, borderline. Any smaller, and they would be brown dwarfs, failed stars, not quite massive enough to ignite hydrogen. These tiny red dwarfs will outlive everything, burning for trillions of years, long after the universe has grown dark and cold. The oldest known star, HD 1140283, Methuselah, estimated at over 14 billion years old, nearly as old as the universe itself, metal poor, ancient, a relic from the early cosmos. It challenges our understanding. How can a star be almost as old as everything? There's tension, uncertainty, mystery, like the edge of sleep, where questions blur and answers don't matter anymore. The longest living stars, tiny red dwarfs, will burn for 10, 20, even 100 trillion years. But the universe, only 14 billion years old, means not a single red dwarf has yet died of old age. They're still in their infancy, all of them, burning, waiting, patient beyond comprehension. The shortest-lived stars, blue hypergiants, massive beyond measure, burn through their fuel in mere millions of years. Eta Carinae, 100 times the Sun's mass, shining with the light of 5 million suns, unstable, erupting, surrounded by the homunculus nebula formed from previous outbursts. It could explode tomorrow or in 100,000 years. We don't know, but when it does, it will shine, brighter than Venus, visible in daylight, briefly, before fading forever. Of all the stars in the galaxy, perhaps 400 billion, only about 5,000 are visible to the naked eye on the darkest nights. The rest, too faint, too distant, lost in the cosmic vastness. And even those 5,000, you can only see half at any time. the half above your horizon, while the other half waits, patient, turning with Earth, appearing, disappearing, eternal rhythm, constellations. The patterns we see are mostly illusions. Stars that appear close together may be separated by hundreds of light years. The 3 stars of Orion's belt, Alnitak, Alnilam, Mintaka, appear aligned, but lie at distances of 800, 1300, and 900 light years, respectively. Not a real group, just a chance alignment from our perspective, like faces in clouds, patterns in static, meaning we create these patterns. Once guided navigation, sailors used the stars, finding latitude from the North Star's height, finding directions from rising and setting points. Polynesian navigators crossed thousands of miles of open ocean, using only stars, wave patterns, bird flights. The sky was a map written in light, telling them where they were, where they could go. Ancient myths written in stars. Every culture looked up and told stories. The Greeks saw hunters and bears. The Chinese saw dragons and palaces. The Aboriginal Australians saw ancestral beings walking the sky, all different, all true in their way. Stories we project onto the indifferent stars, making meaning from light. Our sun is halfway through its life, 5 billion years old, 5 billion more to go, currently stable, burning hydrogen in its core. But in about 1 billion years, it will brighten, enough to boil Earth's oceans. In 5 billion years, it will swell into a red giant, engulfing Mercury, perhaps Venus, possibly Earth. Then it will puff off its outer layers, forming a planetary nebula, leaving behind a white dwarf, cooling, fading, becoming a black dwarf after trillions of years. Earth's day stretching into weeks, months, as tidal forces slow its rotation, until finally the sun, dark, cold, becomes one with the darkness, the end of our beginning. But that's far, so far. Let your mind release it. There's only now, only this moment, this breath. In, out, heavier, heavier, sinking into comfort, into rest. Inside a star, energy travels outward, from the core where it's created, toward the surface. But how it travels depends on the star's structure. In massive stars, radiation dominates. Photons bounce from atom to atom, a random walk, taking thousands of years to escape, traveling a few centimeters, then being absorbed, re-emitted, absorbed again. A single photon could take 100,000 years to journey from core to surface, though it would cover the distance in seconds if it could fly straight. In smaller stars like our sun, the outer layers are convective. Hot plasma rises, cools, sinks, rises again, like boiling water. Giant convection cells, larger than Earth, churning, moving heat, creating the granular pattern visible on the sun's surface. Each granule a convection cell, rising hot plasma in the center, falling cooler plasma at the edges, lasting minutes, replacing, renewing, endlessly. The radiative core, deeper down, where photons bounce, is calm, stable, pressure and temperature increasing steadily toward the center. At the very core, our sun's core, temperature reaches 15 million degrees, pressure 200 billion times Earth's atmosphere. Here, hydrogen fuses, releasing energy, light, heat, the power that warms Earth, that enables life, that... But your thoughts are drifting now, following the light, outward, upward, into dreams. Stellar opacity, how opaque a star's material is, determines how easily photons can escape. Higher opacity, more scattering, slower energy transport. Iron, in the outer layers of some stars, increases opacity, trapping energy. This can trigger instability, pulsations, as pressure builds and releases, rhythmic, like breathing, like the slow pulse of your heartbeat now. Thump, thump, steady, distant, luminous blue variables, massive unstable stars undergo enormous eruptions, shedding solar masses of material. Eta Carinae's great eruption in the 1840s briefly made it the second brightest star in the sky, though it lies 7,500 light-years away. The eruption ejected 10 solar masses, creating the homunculus nebula. We still don't understand why. Instability in giants, mysteries unsolved, Wolf-Rayet stars show emission lines, not absorption. Their cores exposed, hydrogen envelope blown away by fierce stellar winds, burning helium and heavier elements, surface temperature 50,000 degrees. They live fast, only a few 100,000 years in this phase before exploding as supernovae, their winds, enriching space with nitrogen, carbon, oxygen, building blocks for future worlds, carbon stars, cool red giants, where carbon becomes more abundant than oxygen in the atmosphere. This changes everything. Carbon molecules dominate. Carbon monoxide. Polyatomic carbon chains. The star glows deep red. Sutai, surrounded by dust shells of pure carbon, graphite and carbonaceous compounds, drifting outward, seeding space. Some of this carbon eventually found its way into you. Oxygen-rich stars, more common, where oxygen exceeds carbon, form different dust, silicates, compounds like those in Earth's crust. These stars create the minerals that eventually form rocky planets. The oxygen you breathe was exhaled by dying stars billions of years ago. Each breath connects you as to stellar death, to cosmic cycles, to infinity. Breathe in, breathe out, slowly, deeply, releasing everything. Barium stars show unusual amounts of barium and other heavy elements in their spectra. They're always in binary systems. Their companion, now a white dwarf, was once a giant star that created barium through neutron capture, then transferred this enriched material before dying. Evidence of stellar vampirism, mass transfer, interaction. Even dead stars shape the living, chemically peculiar stars. break the patterns, some rich in mercury, europium, other rare elements, some depleted in helium, enriched in helium. We don't always know why. Stellar evolution is complex. Mixing, diffusion, radiation pressure, magnetic fields, all influencing what rises, what sinks, what shows on the surface. Each star slightly different, slightly unique, like snowflakes, like dreams, infinite variation. Stellar aging leaves markers. The ratio of carbon to nitrogen changes as stars evolve. Lithium depletes. Rotation slows as stars age. Magnetic braking. Stellar winds carrying away angular momentum. By measuring these markers, we can estimate a star's age, reading stellar time in chemistry and motion. Let your body age now, but backward. Feel yourself growing younger, lighter, muscles softening, face smoothing, until you're so young, so new. You haven't been born yet, just potential, just energy, waiting in the dark. This is the ultimate relaxation, returning to before, to nothing, to peace. In the far future, trillions of years from now, star formation will cease. The universe will expand. Galaxies drift apart. Gas becomes too diffuse to collapse. The last stars will form, ignite, burn, and die. Eventually, only brown dwarfs and red dwarfs remain, burning dimmer, dimmer. The stars will fade, one by one, until the universe goes dark. No more light, no more heat, just black holes and dead stars, drifting through expanding void. The stelliferous era will end, and a darker age begins, but that's so far, unimaginably far. Let it go. Release the future. There's only now, only this darkness, behind your eyelids, comfortable, warm, safe. Stars in stellar halos orbit the galaxy in elongated paths, taking them far above and below the galactic disk. These are ancient stars, population 2, metal poor, formed when the galaxy was young. They remember what we've forgotten, the galaxy's violent youth, when it consumed smaller galaxies, scattering their stars into the halo, where they orbit still, lonely, separate from the disk, witnesses to deep time. Our galaxy has consumed dozens of smaller galaxies, their stars, now part of the Milky Way, but on different orbits, moving differently than disk stars. Stellar archaeology, reading motions and chemistry, can identify which stars came from which conquered galaxy. The Sagittarius dwarf elliptical galaxy, currently being absorbed, its stars streaming, mixing, disappearing into our galaxy's population. Cosmic assimilation, merger, inevitable. Some stars visible to the naked eye have planets. We know this now. Thousands of exoplanets discovered, orbiting other suns. Some stars, like Fomalhaut, surrounded by debris disks, dust and planetesimals, visible in telescopes, evidence of planetary systems, forming or existing. Each star, potentially a sun to other worlds, other skies, other eyes looking up. Your eyes are closed now, or should be. Let them stay closed, sealed gently, pressure releasing, darkness complete. You don't need to see, just feel the weight of your body heavier, heavier, melting into the mattress, becoming one with stillness. Stellar convection zones in the sun extend from 70% of the radius outward to the surface. This churning layer generates the sun's magnetic field through the dynamo effect. Moving charged plasma creates electric currents, which create magnetic fields, which affect the plasma motion, a feedback loop sustaining itself, reversing every 11 years. Sunspot cycles, magnetic pole flips, regular, mysterious, beautiful mathematics emerging from chaos. Energy transport depends on stellar mass, low mass stars, fully convective, stirring their entire interior. This means they can burn all their hydrogen, not just the core, making them even longer lived. High mass stars, radiative throughout most of their interior. Only their outer layers convect, energy trapped deeper, leaking out slowly, building pressure, creating instability in the most massive stars. The stellar mass-luminosity relation tells us that luminosity increases dramatically with mass. A star 10 times more massive shines thousands of times brighter. This is why massive stars die young, burning through fuel, like a fire with too much oxygen. Brilliant, wasteful, brief. While small stars conserve, endure, outlast. Some stars don't behave. Classical B stars, B-type stars that show hydrogen emission lines, indicating surrounding gas disks. They rotate so fast, near breakup velocity, flinging material into orbit around themselves, creating disks that absorb and re-emit light. Why they rotate so fast, unclear. Perhaps they're merger products, or were spun up by a companion. Mysteries, accumulating like stars, too many to count. Your heartbeat has slowed now. Thump, thump, longer between beats. Your metabolism slowing. Body temperature dropping slightly. This is healthy. This is sleep approaching. The edge of consciousness, where everything becomes soft, indistinct, acceptable. Stellar mergers happen sometimes, especially in dense star clusters. Two stars, orbiting too close, spiral inward, tidal forces shredding them, until they merge, becoming one. The result, a blue straggler, a star that appears younger than it should. Too massive, too blue. For the cluster's age, it's been refreshed, born again through fusion of bodies. When stars collide, the results depend on their masses and velocities. Sometimes complete disruption, sometimes accretion and growth. In the dense cores of globular clusters, collisions might happen once every 1,000 years, building strange objects. We've found stars with unusual compositions, likely collision products, each one evidence of cosmic violence, smoothed over, disguised as normalcy. Mass transfer in binaries can be stable, slow, drip by drip, through the Lagrange point where gravity balances, or unstable, rapid, common envelope evolution, where one star swells so large it engulfs its companion. The companion orbits inside, spiraling through the giant's atmosphere, friction, heating, ejecting the envelope entirely, leaving two cores orbiting close, a white dwarf and main sequence star, or two white dwarfs, or a neutron star and companion. Stellar intimacy at its most extreme. Sometimes, when a white dwarf accretes matter from a companion, the hydrogen piles up on its surface, pressure building, temperature rising, until it ignites. Not fusion in a controlled core, but runaway fusion on the surface. A nova, brief explosion, blowing off the accreted layer. The white dwarf survives, continues accreting, building to another nova. Years or decades later, recurrent novae, pulsing, erupting, caught in a cycle they cannot escape. If the white dwarf accretes enough mass, approaching 1.4 solar masses, the Chandrasekhar limit, electron degeneracy pressure, can no longer hold it up. The entire star undergoes runaway carbon fusion in seconds. Thermonuclear explosion, type Ia supernova, completely destroying the white dwarf, leaving nothing. These supernova, all roughly the same brightness, making them excellent standard candles, measuring cosmic distances, revealing the accelerating expansion of the universe, dark energy. But those are thoughts for waking minds. Your breathing is shallow now, barely moving, chest rising, falling, so slightly. This is good, this is right. Let it slow even more. Each breath taking longer until you almost forget to breathe, and then remember and take another soft, shallow breath. Stellar spectroscopy reveals motion through the Doppler shift. Light from approaching stars shifted toward blue, receding stars toward red. This tells us stellar velocities, orbital motions in binaries, rotation rates, even the convection cells on the sun rising toward us, sinking away, blue shifted, red shifted, motion written in light if you know how to read. Radial velocity measurements have discovered most exoplanets. A planet's gravity tugs its star, making it wobble slightly. The star's spectrum shifts, blue, red, periodic, revealing the planet's mass and orbit. Even though we can't see the planet, we see its effect on the light. Gravity's fingerprint, invisible touch, making visible the hidden. Some stars are spectroscopic binaries, too close to resolve, even in powerful telescopes, appearing as single points, but their spectra show two sets of lines, shifting back and forth as they orbit, revealing the double nature, hidden but knowable, like your consciousness now, single but containing multitudes, thoughts, dreams, memories, all orbiting in the dark. The first stars in the universe changed everything. Before them, the universe was simple: hydrogen, helium, trace lithium, that's all. After them, carbon, oxygen, nitrogen, iron, all the complexity, all the chemistry, all the possibilities, and came from stars dying. Life is made of stardust, literally, not metaphorically. the calcium in your bones, forged in stellar cores, the oxygen you breathe, stellar fusion product. You are a way for the universe to know itself, to feel, to dream. Let yourself dissolve into that awareness. You're not separate from stars. You're made of them, part of the same cosmic cycle: birth, life, death, rebirth. Your atoms, once inside a star, will someday return to stars. Everything is borrowed. Everything returns. Nothing is lost, only transformed. Stellar nucleosynthesis follows the curve of nuclear binding energy. Fusion releases energy up to iron, beyond iron. Fusion requires energy, so stellar cores stop at iron, but supernovae provide that energy during collapse and explosion, allowing formation of heavier elements: gold, platinum, uranium, all requiring supernovae. Your gold ring, if you wear one, contains atoms forged in unimaginable violence, now circling your finger, quietly, marking time, marking love, marking impermanence. The origin of elements tells a story. Hydrogen and helium from the Big Bang, lithium, beryllium, boron from cosmic ray spallation, carbon, oxygen, nitrogen from stellar fusion, iron from supernova cores, gold, uranium from neutron star mergers. Each element has a birthplace, a story. Everything from somewhere going somewhere else. Cosmic recycling is efficient over billions of years. Gas ejected by dying stars mixes with the interstellar medium. Shock waves from supernova compress this gas, triggering new star formation. The cycle continues. Each generation of stars, slightly enriched, the universe, learning, complexity increasing, until, eventually, stars with planets, planets with water, water with life, life with consciousness, consciousness, wondering about stars. Your consciousness is fading now. Thoughts, slowing, becoming, dreamlike, random associations, memories mixing with imagination. This is sleep, approaching, welcoming. There's nothing to fear, nothing to do. Just let go. Heavier, heavier, sinking into the dark. Galactic evolution, driven by stars. Their light ionizes gas. Their winds create bubbles and shells. Their supernovae shock and heat the interstellar medium. They create heavy elements that enable planet formation. They regulate star formation through feedback. The galaxy is not static, but alive, changing, shaped by stellar birth and death over billions of years. The first starlight ended the cosmic dark ages about 100 million years after the Big Bang. Before that, the universe was opaque, neutral hydrogen absorbing all ultraviolet light. The first stars, massive and hot, ionized bubbles around themselves. These bubbles grew, merged, eventually fuller. The entire universe be ionized and became transparent. Cosmic dawn. We can't see those first stars, but we see their effect in the cosmic microwave background, in the formation of galaxies, in the chemistry of ancient stars. Globular clusters are time capsules. They're stars, all formed together billions of years ago. By studying them, we learn about stellar evolution, watching stars at different life stages, all the same age, like a snapshot of a population. Some are on the main sequence, some are red giants, some white dwarfs, all telling the story of stellar aging, death, transformation. Stars in globular clusters experience cosmic density. In the core, hundreds of stars per cubic light year compared to less than one in the solar neighborhood. This density leads to interactions, close encounters, collisions, binary formation, exotic objects, blue stragglers, millisecond pulsars, low-mass X-ray binaries, all products of stellar interaction in the cosmic crowd. Open clusters are younger, less tightly bound. The Pleiades, barely 100 million years old, still embedded partially in the nebula of their birth. Hot blue stars haven't yet died. Eventually, tidal forces from the galaxy will disperse them. Their stars, scattered, indistinguishable from field stars. The Sun might have formed in an open cluster 4.5 billion years ago. Its siblings, long since separated, scattered across the galaxy, unknowable, lost. Imagine your body dissolving, atoms separating, drifting apart, each atom finding its own path through space, eventually ending up in different stars, different planets, different people. You scattered, dispersed, but not destroyed, just redistributed. This is what happens to everything eventually. Release into the inevitable. Some stars near the galactic center orbit the supermassive black hole so closely that relativistic effects are measurable. S2 orbits every 16 years. At closest approach, gravity so strong, time slows measurably. Clocks on S2 would run slower than ours. General relativity confirmed by watching stars dance around darkness. The record-breaking massive star, R136A1, weighs about 300 solar masses near the theoretical maximum. At this mass, radiation pressure nearly tears the star apart. Its stellar wind, so powerful, it loses a solar mass every few million years. It cannot last. Already, it's probably shrinking, losing mass. In a few million years, it will explode or collapse, leaving behind a black hole, maybe 100 solar masses. The most massive stars become the most massive remnants, the smallest known stars. EBLMJ Euro 5 Facer 57A, barely larger than Saturn, only 8% of the Sun's mass, barely massive enough for fusion. Its surface, cool, 2000 degrees, glowing deep red, almost invisible. But it will outlive everything, burning for trillions of years, patient, eternal. The universe's last candles when everything else has gone dark. Methuselah star HD 10283 appears almost as old as the universe. This creates paradox, tension, but measurements have uncertainties. The star's age, uncertain by 1 billion years. The universe's age, uncertain by hundreds of millions. Within uncertainties, they reconcile, barely. Still, it reminds us how little we truly know, how much remains mysterious, unresolved. Let that uncertainty calm you. You don't need answers, just acceptance of mystery, of not knowing. Stars visible to the naked eye from Earth, about 5,000, but you have never seen that many. Light pollution, haze, horizon. On a perfect dark night, from a mountaintop, you might see 3,000. Most people in cities see dozens, maybe hundreds. The stars fading, not dying, just hidden by our light, still there, waiting, patient, shining, whether we see them or not. Constellations are cultural, arbitrary. The Big Dipper, called the Plough in Britain, the Saucepan in Australia, part of Ursa Major, the Great Bear in Greek tradition. But Chinese astronomers saw different patterns. Aztec astronomers, different still, all looking at the same stars, seeing different stories, all equally valid, all equally invented. The stars don't know, don't care what we call them. They simply are. Let your thoughts become like that, simply existing, without narrative, without meaning, just sensation, breathing, heartbeat, pressure, warmth. Nothing more needed, nothing more wanted, just being in darkness, in silence, in peace. Ancient navigation by stars required memory, knowledge passed down. Polynesian navigators memorized star paths, rising points, setting points. They knew when Arcturus rose, they were at a certain latitude. When Sirius set, they should turn, sailing thousands of miles by starlight and memory, finding tiny islands in vast ocean. The stars were map and compass, unchanging guides in trackless water. But stars do move, proper motion, gradually changing constellations. 10,000 years ago, the Big Dipper looked different. 10,000 years hence, different still. Dubhe, moving one direction, Alcade another. Eventually, the dipper shape will deform, unrecognizable. All patterns, temporary, all structures, dissolving over time. Your body knows this, cells replacing, atoms exchanging. You are not the same, physically, as 7 years ago. Every atom replaced, yet you remain somehow, same pattern, different material, like constellations, like stars, like everything. Ship of Theseus, are you still you? Of course. And also, no. Let the paradox dissolve into sleep. Myths written in stars, Greek heroes placed in the sky, Orion, the hunter, Scorpius, the scorpion, eternally opposite. When one rises, the other sets. The story says Scorpius killed Orion, so they were placed apart forever. But it's just coincidence, geometry, our pattern-seeking minds making meaning from random arrangements, beautiful, but arbitrary. Aboriginal Australians saw the dark spaces between stars as constellations. The emu in the sky, formed by dark nebulae. In the Milky Way's band, visible only from the southern hemisphere, only with dark skies, they navigated by darkness as much as light, recognizing absence as meaningful as presence. Learn from this. In sleep, we navigate darkness. We find rest in absence of light, absence of thought, absence of effort. The darkness is not enemy, but friend. Embrace it, sink into it, let it hold you completely. Nothing to fear, only release. How do we know how old a star is? They don't wear rings like trees. They don't shed layers. We can count. We must be clever, patient, reading subtle signs, written in light, in motion, in vibration. Let your body settle deeper as we explore the methods of stellar dating. Each technique a whisper, a clue, revealing deep time. Gyrochronology uses rotation to estimate age. Young stars spin fast, rotating in days or even hours, but over time, stellar winds carry away angular momentum. The star slows predictably, measurably, like a spinning top, gradually losing speed. A star's rotation period, combined with its mass, reveals its age with reasonable precision. The sun rotates once every 25 days at its equator. This tells us it's middle-aged, about 5 billion years. Young stars in the Pleiades, only 100 million years old, spin every few days. Ancient stars in globular clusters rotate every 50, 60 days. Slower, slower, like your thoughts now, winding down, losing momentum, approaching stillness. But rotation alone isn't enough. We need more, deeper information from inside the star where we cannot see. So we listen to stellar sound waves, to vibrations, traveling through stellar interiors. Astroseismology, the study of stellar earthquakes, or rather, starquakes. Sound waves making stars ring like bells. Feel your body resonating with your heartbeat. Thump, thump, the bed beneath you, vibrating slightly up with each pulse. Stars do this too, but with sound waves propagating through their gaseous bodies. These waves, created by turbulence in convective zones, bounce, reflect, interfere, creating standing wave patterns, oscillations, visible on the surface. Stellar sound waves, too low for ears, far below human hearing. Periods of minutes, hours, days. We detect them through Doppler shifts, the star's surface, moving toward us, then away, rhythmically, parts rising, parts falling, the star breathing, pulsing, revealing its secrets. Through vibration, these oscillations tell us everything. The waves travel at different speeds, through different density, temperatures as compositions. By measuring thus many oscillation modes, we map the stellar interior like a CT scan, but using sound instead of X-rays, revealing the size of the core, the depth of convective zones, the density profile, the internal rotation, everything from surface vibrations, Let your awareness vibrate now, oscillating between waking and sleeping, neither fully one nor the other, just pulsing gently back and forth like stellar sound waves, like ocean tides, rhythmic, hypnotic, endless, stellar interior mapping through astroseismology reveals differences we couldn't see otherwise. Two stars, identical in brightness, temperature, surface chemistry, might have completely different interiors, one with a large convective core, one without, one rotating rapidly inside, one slowly. The surface hides complexity. Only vibrations reveal truth. Our sun oscillates in millions of different modes, each mode a different pattern of standing waves. Some waves penetrate deep, sampling the core. Others stay shallow, probing outer layers. By measuring them all, we know the sun's interior better than Earth's. We've mapped it completely, precisely, beautifully. A star, transparent through sound, surface granulation, visible on the sun. Those cellular patterns are convection cells, hot plasma, rising in centers, cooling, sinking at edges, each granule about 1,000 kilometers across, lasting 10 minutes before dispersing, reforming continuously. The surface boiling, churning, transporting heat from below. These granules create turbulence, which generates sound waves, which create the stellar oscillations. Everything connected: convection, sound, oscillation, revelation, a chain of cause and effect, leading from stellar interior to our telescopes, to our understanding. Let understanding fade now. You don't need to know, just feel the rhythm, the pattern, the endless vibration. Stellar limb darkening, noticed when viewing. The sun's disk, the center, appears brighter than the edges. This happens because, looking at the center, we see deeper into hotter layers. Looking at the edge, we see only the cooler surface. The effect tells us about temperature gradients, atmospheric structure, opacity. Simple observation revealing deep complexity. Different wavelengths show different amounts of limb darkening. Blue light more pronounced than red. This tells us temperature changes with depth, each color sampling a different layer. By measuring carefully, we reconstruct the temperature profile of the stellar atmosphere. Invisible structure made visible through patient observation. Stellar albedo. How much light a star reflects. Wait, stars don't reflect, they emit. But in binary systems, one star's light can fall on another, some fraction absorbed, some scattered. The albedo depends on atmospheric properties, surface features. For most stars, albedo is low. They absorb more than reflect. But measuring it in eclipsing binaries tells us about stellar atmospheres. Yet another way to probe what cannot be seen directly. Your mind is absorbing these words, some fraction retained, most slipping away. forgotten immediately. This is perfect. You don't need to remember. Just let information wash over you like starlight, falling on your closed eyelids, warming but not illuminating. Star formation efficiency puzzles astronomers. In a giant molecular cloud, thousands of solar masses of gas, only a few percent become stars, the rest dispersed or remains as gas. Why so inefficient? What stops star formation before the cloud is consumed? The answer is feedback. Massive stars, once formed, disrupt their nursery. They emit intense ultraviolet radiation, ionizing surrounding gas, creating H2 regions glowing pink in photographs. This ionized gas heats up, expands, pushing outward, compressing some regions, dispersing others. The first stars prevent later stars from forming. Self-limiting process. Stellar winds from young massive stars blow bubbles in the molecular cloud, sweeping gas away, reducing density, making further collapse difficult. Then supernovae. When the first massive stars die, exploding, shock waves blast through the cloud, shredding it, dispersing it. Star formation stops. The cloud destroyed by its own children. But sometimes feedback triggers new star formation instead of preventing it. Triggered star formation occurs when shock waves from supernovae or stellar winds compress adjacent gas, increasing density locally, starting collapse. That wouldn't have happened otherwise. Creation through destruction, birth from violence. Let your muscles be shocked and deeper relaxation, each breath a wave, releasing tension, each exhale dispersing tightness. Nothing forced, just allowed. Gentle compression leading to release. The body knows how to let go. If you stop interfering, shock waves in starbirth, visible in many nebulae. The Orion Nebula shows bow shocks around young stars, glowing arcs where stellar winds meet ambient gas, compressing it, heating it, making it shine. These shocks can trigger further star formation in the compressed layers, cascading through the cloud. Sequential star formation, generations of stars, each triggering the next. Feedback from massive stars dominates galactic evolution. Their ionizing radiation, their winds, their supernovae inject energy into the interstellar medium, heating it, stirring it, preventing too rapid star formation, regulating the process. Without feedback, galaxies would form stars too quickly, exhausting their gas in 1 billion years. Instead, star formation continues for billions of years. Feedback creates sustainability, balance through violence, ionizing radiation from stars, photons energetic enough to strip electrons from atoms. Only the hottest stars emit significant amounts. O-type stars, surface temperatures 40,000 degrees or more. Their ultraviolet light, invisible to eyes, but powerful. Each photon carrying enough energy to ionize hydrogen. These photons create bubbles of ionized gas around massive stars, Strömgren spheres, perfectly spherical in uniform gas, irregular in reality, shaped by density variations, stellar winds, motion. The Orion Nebula glows because of 4 hot stars, the trapezium at its center. Their ultraviolet light ionizes the gas. The electrons recombine with protons, emitting visible light, mostly red from hydrogen. This is why emission nebulae glow pink, not reflection, not starlight scattered, but fluorescence, gas, absorbing ultraviolet, emitting visible, transformation of invisible to visible. Stars shaping nebulae everywhere. The Eagle Nebula's pillars, sculpted by radiation from nearby massive stars, photoevaporation, peeling away the pillars' outer layers like wind, eroding rock but using light instead of air. The pillars shrink over thousands of years, eventually thus consumed completely, disappeared, temporary structures captured by telescopes existing only briefly in cosmic time. Inside the pillars, small dense knots resist evaporation. These are eggs, evaporating gaseous globules, each one possibly a forming star, protected temporarily by surrounding material, but the radiation catches up eventually, dispersing the cocoon, exposing the young star, or destroying it. Before birth completes, star formation, racing against destruction. Some win, some lose. Your thoughts are evaporating now, like gaseous globules exposed to light, thinning, dispersing, leaving behind only darkness, no resistance necessary. Let them go. Each thought temporary, none worth holding, all evaporating into the dark. Bow shocks around fast stars form when runaway stars plow through interstellar gas like boats through water. They push gas aside, creating compression waves. The gas, heated by compression, glows infrared, visible in Spitzer images, red arcs, pointing backward, showing the star's motion through space. Zeta Ophiuchi creates a spectacular bow shock, moving at 24 kilometers per second, 30 times faster than a rifle bullet. The shock spans several light years, glowing like a cosmic wake. The star itself, hot, blue, massive, ejected from its binary system when its companion exploded, now fleeing alone, creating beauty from tragedy. These fast stars, runaway stars, can escape their birth clusters, young, travel hundreds of light years before dying, seeding distant regions with heavy elements when they explode, spreading stellar products far and wide, galactic mixing through stellar motion. Everything connects. Eventually, nothing stays isolated. Everything disperses. Feel yourself dispersing. Thoughts, sensations, sense of self, all spreading, thinning, losing coherence. This is not death. This is sleep, This is rest. This is not necessary. Let it happen. Let go. Completely. Stellar debris disks surround many young stars, dusty pancakes of material left over from star formation. This material eventually forms planets or is blown away or falls into the star. We see these disks in infrared. The dust, warmed by starlight, glows, revealing circumstellar structure, invisible light. Beta Pictoris, one of the first debris disks discovered, edge on from Earth. A thin line extending hundreds of AU gaps in the disk suggest planets sweeping material from their orbits. We've even imaged one planet directly, a giant world, young, hot, still glowing from formation. The disk is a laboratory showing us planet formation in action. These disks fade over time, collisions grinding dust to smaller particles, radiation pressure blowing particles outward into space. After 10 million years, most disks dissipated. The planets, if any, already formed. The system cleaned up, mature. Our solar system once had such a disk 4.5 billion years ago. Now, only trace amounts remain. Asteroid belt, Kuiper belt, remnants of what was circumstellar envelopes, different from disks. These are spherical shells around evolved stars, red giants, blowing off their outer atmospheres slowly, gently. The gas expands, cools, molecules form, dust condenses. The envelope grows, becoming enormous, light years across, eventually dispersing into interstellar space. IRC plus 10216, a carbon star, has the thickest circumstellar envelope known. The star itself, invisible, buried inside layers of dust. We see only the envelope, glowing infrared, pulsing as the star beneath pulsates. The star dying, cocooned in its own exhalations. Soon, the envelope will dissipate, revealing a white dwarf at the center. The transformation complete. Planetary nebulae are circumstellar envelopes lit up. When the central star becomes hot enough, its ultraviolet light ionizes the previously expelled gas, making it glow. Beautiful colors: red from hydrogen, green from oxygen, blue from helium. These nebulae expand over thousands of years, fading as they spread, thinning until invisible. The gas returned to the interstellar medium, enriched, changed, ready for recycling. Let yourself be recycled now. Energy, that was you, returning to the universe. Tension dispersed, thoughts dissolved, self forgotten. Only breath remains in, out, slow, shallow, barely there. Stellar death timeline here depend entirely on mass. Low mass stars, red dwarfs, burn for trillions of years, gradually cooling, shrinking, fading, never exploding, never creating planetary nebulae, just cooling forever, becoming black dwarfs, Eventually, though the universe isn't old enough yet for any to exist, solar mass stars, like our sun, live 10 billion years, stable on main sequence 9 billion years, then red giant phase 1 billion years, helium burning 100 million years, asymptotic giant branch 1 million years, planetary nebula 10,000 years, white dwarf forever, the timeline accelerating toward the end, like life, slow beginning, rapid conclusion, massive stars, 8 solar masses or more, live fast, die young, main sequence, 10 million years, red supergiant, 1 million years, helium burning, 100,000 years, carbon burning, 1,000 years, neon burning, 1 year, oxygen burning, 6 months, silicon burning, 1 day, then iron core and collapse in less than a second. The end. Sudden, violent, spectacular. The most massive stars, over 100 solar masses, live only 2 or 3 million years. Barely time to orbit the galaxy. Once born, lived, died, in cosmic eye blink, their entire existence shorter than Earth's ice ages, shorter than human civilization, brief but important. They create heavy elements, they shape galaxies, they trigger star formation. Their brevity makes them crucial. Your consciousness is brief too, in cosmic terms, infinitesimal, decades at most, then gone, like a massive star, bright, brief, returning to darkness. Does it matter how long you exist, or only that you existed? Questions for waking hours, not for sleep. Let them dissolve, unanswered, into the dark. The stellar death timeline for intermediate mass stars, 2 to 8 solar masses, includes additional phases. After helium burning, they don't ignite carbon. Core shrinks, heats, but never reaches ignition temperature. Layers burn in shells. Hydrogen and helium. The star becomes highly unstable, pulsating, shedding mass, thermal pulses every few thousand years. Dramatic, chaotic, unpredictable. These thermal pulses dredge up fusion products from deep inside, carbon, nitrogen, heavy elements created by neutron capture. They appear on the surface, changing the spectrum, enriching the wind. Some stars become carbon stars during this phase. Others, barium stars, technetium stars, all showing internal products brought to surface, internal becoming external, hidden, revealed. Your internal state is becoming external, relaxation spreading outward from core to surface, muscles releasing, skin softening, face smoothing, the boundary between inside and outside blurring. You're not contained anymore. You're spreading, expanding, merging with surroundings. Eventually, after enough thermal pulses, the envelope is gone, expelled completely, the core exposed, hot, tiny, dense. Ultraviolet light ionizes the expelled gas, creating planetary nebula, lasting 10,000 years, then fading. The white dwarf remains cooling over billions of years. The end of intermediate stars, gentle, beautiful, compared to supernova violence. Stellar death is not ending, but transformation. The matter doesn't disappear. It spreads, enriches, mixes, seeds, new stars, new planets, new life. Perhaps nothing ends, really, just changes form, like you, changing form from wakiness to sleeping. Not death, just transformation into another state. Sound waves still echoing through stars, vibrations continuing long after we stop listening, stars still forming in nebulae despite feedback, bow shocks still glowing around runaway stars, debris disks still circling, young stars, all these processes continuing, whether observed or not. The universe doesn't need witnesses, it simply is. And you don't need to witness anymore. Let your observation cease. Let awareness fade. You've seen enough, learned enough, experienced enough. Now, rest, release into the darkness that existed before stars, that will exist after stars. Eternal darkness, welcoming, infinite home, dating stars through gyrochronology, astrophysical, chemistry, rotation, all methods converging on truth. But truth doesn't matter in sleep. Only surrender matters. Only letting go. Only drifting deeper into silence, into stillness, into nothing. The stars will keep vibrating, keep spinning, keep dying while you sleep. And that's perfect. That's how it should be. The universe continuing while you rest. No guilt, no worry, no need to stay awake. Just permission to fade completely, totally. Now, our sun, in 5 billion years, will swell, engulfing the inner planets. Its outer layers puffed away, forming a planetary nebula, the core contracting, becoming a white dwarf, Earth-sized, glowing, cooling over billions of years. Eventually, after timescales longer than the current age of the universe, it will crystallize. Carbon and oxygen arranged in lattice structures. A stellar diamond, cold, dark, invisible, floating through space forever. But between now and then, 5 billion years of stability, warmth, light, the sun, reliable, steady, rising, setting, day after day, generation after generation, species after species. It has been there for everything. Every dinosaur, every tree, every human thought. It's light, reaching Earth in 8 minutes, having travelled from the core for 100,000 years. Each photon, ancient, when it finally touches your skin. Let your skin relax now, pores opening, releasing, tension flowing out into the air, into space. You don't need to hold anything anymore. Let the sun, the stars, the universe hold you instead. They're so much stronger, so much more patient. They will outlast all worry, all fear, all pain. In 1 billion years, the sun's increasing luminosity will evaporate Earth's oceans, the planet becoming Venus-like, hot, dry, lifeless. But life might have moved by then to the moons of Jupiter, to the stars, or might be gone, evolved beyond recognition, or extinct. The universe continues regardless. Stars don't mourn, don't celebrate. They simply burn and die, and in dying, create the conditions for new stars, new planets, possibly new life. The cycle continues, whether witnessed or not. Your breathing is so quiet now, barely audible, barely felt. This is the edge, the boundary between waking and sleep. You can cross it any time. There's no effort required. Just stop trying, stop listening, stop following. Let the words wash over you. There's meaningless. You're like rain, like waves. Just sound fading into silence. Stellar opacity determines much. High opacity stars trap radiation, building pressure, leading to pulsation. Low opacity stars release energy smoothly, remaining stable. Iron in stellar atmospheres increases opacity dramatically. This is why the iron bump creates instability in massive stars. Energy trapped, then released, creating the pulsations we see in Cepheids, in our Lyrae, in other variables. The star breathing in and out, swelling, contracting, a cosmic bellows. Inside massive stars, layers form like an onion, hydrogen fusing in a shell, surrounding helium fusing core, surrounding carbon fusing region, surrounding neon, oxygen, silicon, and finally iron. Each layer at different temperature, different pressure, different time scale. The silicon burning layer lasts only days before creating enough iron to doom the star, while the hydrogen layer might burn for thousands of years. These layers don't mix generally. Density stratification keeps them separate. Heavy elements sink, light elements rise, but sometimes in convective zones, mixing occurs, dredge up, bringing fusion products to the surface, changing the star's spectrum, revealing us what's happening in the depths, like dreams, bringing unconscious material into awareness, briefly, before it sinks again. Your unconscious mind is taking over now. The rational mind, quieting, releasing control. You might notice thoughts becoming strange, illogical. This is normal. This is healthy. The dream state approaching. Let it come. Don't fight. Don't analyze. Just observe and let go. Luminous blue variable, the most massive, most luminous, most unstable stars. They vary erratically, sometimes dimming, sometimes erupting. We don't fully understand them. They shouldn't exist. Theoretically, radiation pressure should blow them apart. Yet they persist for thousands of years, defying expectations. Ita Carinae, P. Cygni, Estoradus, beautiful, mysterious, doomed Wolf-Rayet stars, exposed cores showing emission lines of ionized helium, nitrogen, carbon, oxygen, depending on their type. Their winds blow at thousands of kilometers per second, faster than hurricanes, faster than sound, faster than thought, carrying away several Earth masses per year, the star dissolving into space, even as it shines, dying, but spectacularly, beautifully, creating complex nebulae, planetary nebulae, but the terms are blurring now, the definitions sliding, merging into dream logic. Feel your body, merging with the mattress, boundaries dissolving. Where do you end and the bed begin? Hard to say, not important. You're becoming part of the room, part of the darkness, part of space itself, expanding, diffusing like stellar wind, like nebulae, spreading, thinning, disappearing into vastness. Carbon stars create dust. Carbon combines with itself, forming chains, rings, graphite particles. These drift into space, cooling, condensing. Eventually, some might become parts of planets, parts of life. Carbon, the basis of organic chemistry, mostly came from carbon stars. The diamond on someone's finger, the graphite in a pencil, the carbon in DNA, all stellar exhalations breathed out by dying giants. Billions of years ago, oxygen-rich stars, the majority, create silicate dust, silicon, oxygen, forming compounds like quartz, like sand. The grains drift outward, accumulate, eventually end in protoplanetary disks. They stick together, forming asteroids, planets. Earth's crust is mostly silicate minerals from ancient stars. The ground beneath you, the walls around you, made of stardust. Everything connected, everything starborn. Barium stars reveal binary evolution. The barrier, too heavy to form in the current star, must have been transferred from a companion, now dead. Evidence of past interaction, past intimacy, past merger or mass transfer. The star carries the memory in its spectrum, in its chemistry, written permanently in starlight, like scars, like memories testifying to what was. Your memories are fading now, becoming unimportant. What happened today, yesterday, last year, doesn't matter. In this moment, all that matters is letting go, sinking deeper into formless, timeless peace. Memories like stars, distant, faint, flickering out one by one until only darkness remains. Chemically peculiar stars challenge understanding. Magnetic fields might separate elements by atomic weight, causing stratification, or perhaps unusual nuclear processes in their cores. We're not certain. Each peculiar star, a puzzle, potentially revealing new physics or just cosmic randomness, creating outliers, exceptions, beautiful aberrations, stellar aging markers, change over time. Lithium, destroyed by fusion, depletes in old stars, and carbon to nitrogen ratio changes as CNO cycle processes material, rotation slows due to magnetic braking, metallicity increases with galactic evolution. From all these, we deduce age, though with uncertainty, always uncertainty. We measure, we estimate, we guess. The universe keeps its secrets, partially, gracefully. Far future, stelliferous era ending, no more star formation, existing stars burning out one by one. First, the massive blue giants, already gone. Then, solar-type stars, white dwarfs cooling. Finally, only red dwarfs, burning for trillions of years. But even they, eventually, exhaust their fuel. The last star will flicker out in 10 or 100 trillion years. The universe going dark, entering the black hole era where only gravity shapes the void. But before that, so long before that, incomprehensible timescales, let them wash away. You don't need to think about endings, not now. Just this breath, this moment, this soft sliding into sleep. Stellar halos contain the galaxy's oldest citizens, population 2 stars, metal poor, ancient. They orbit in eccentric paths, plunging through the disk, then soaring far above, then plunging again. Elliptical orbits formed when the galaxy was young, violent, chaotic, before the disk settled, before spiral arms formed. These stars remember, they carry the galaxy's history in their motion, their chemistry, their age. Some halo stars might have come from other galaxies, consumed by the Milky Way in ancient mergers, their orbits retrograde, opposite the disk's rotation, their chemistry slightly different, telling of foreign birth. They've been integrated, assimilated, part of our galaxy now, but their origin remains visible to those who know how to look. You contain histories too, in your DNA, genetic memory of ancestors, in your neurons, childhood experiences, in your body, scar tissue, growth rings, marks of time. But right now, let history dissolve. You're not the past, you're not the future, you're just this moment, this breath, this slow descent into nothing. Planets around other stars, now numbered in thousands. We've found hot Jupiters, super-Earths, ice giants, rocky worlds, some inhabitable zones where water could be liquid, some around multiple stars where sunsets show 2 or 3 suns simultaneously, each planetary system unique, teaching us what's possible, what's common, what's rare. Fomalhaut has a debris disk, visible in telescopes, dust, planetesimals, possibly planets, orbiting. The disk has a gap, carved by unseen planets, sweeping their orbits clean. We infer presence from absence, like detecting a person by their shadow, gravity's footprint in the dust, your footprint on the world. What does it matter? Everything you've done, everyone you've known, will be forgotten. Eventually, stars don't remember, planets don't care, the universe, vast and ancient, pays no attention, and this is freeing. There's no pressure, no expectation. You can just be and then not be. And it's all perfectly fine. Stellar magnetic fields generated by dynamo action in convective zones, charged plasma, moving in rotation and convection, creates electric currents, which create magnetic fields, which affect the plasma, feedback loop, self-sustaining. The sun's field flips every 11 years. Sunspot cycle, magnetic activity, rising and falling, predictable, yet chaotic in detail. Some stars have much stronger fields, magnetic stars, with field strengths thousands of times. The suns. These fields affect stellar structure, can halt convection, create chemical peculiarities, produce enormous star spots, covering half the star, caged by its own magnetic field, shaped, constrained, unable to evolve. Normally, you're not constrained, not anymore. The day's obligations, released. Tomorrow's worries, irrelevant. You're free to float, to drift, to sink into infinite softness. Nothing holding you except gravity, gentle, irresistible, pulling you down into sleep. Classical B star, rotating rapidly, near breakup velocity, centrifugal force, nearly overcoming gravity. They fling matter into orbit, forming disks of gas around their equators. These disks absorb stellar light, re-emit it, creating emission lines in the spectrum. Why so fast? We think perhaps stellar mergers, or mass transfer, or just formation with high angular momentum. Mystery remaining. When stars collide in dense clusters, the outcome depends on impact parameter, head-on collision, complete merger, possible supernova, glancing blow, mass stripping, formation of binary. Most collisions, partial, chaotic, creating blue stragglers, rejuvenated stars, appearing younger than their cluster mates, evidence of violence hidden beneath normal appearance, like trauma, buried deep, invisible except to those who know where to look. But you don't need to look anymore. Eyes closed, completely, darkness, total. Let your other senses fade too, sound, becoming irrelevant, touch, minimal, smell, forgotten, taste, gone. Only a faint awareness of existing, and even that, slipping away. Mass transfer in close binaries through Roche lobe overflow. When one star expands, becoming a giant, its outer layers cross the boundary where the companion's gravity equals its own. Material streams through the inner Lagrange point onto the companion, sometimes steady, sometimes unstable. Common envelope evolution, spiral in, merger, or tight binary formation. Recurrent novae, white dwarfs accreting from companions, building hydrogen layers until ignition. Thermonuclear runaway on the surface. Explosion, ejecting the layer. The white dwarf survives, continues accreting. Years later, another nova, T. Pixidis, Oris Oppiuchi, Euscorpii, erupting every few years or decades, recycling matter between stars, eternal dance of give and take. Your heartbeat so slow now, thump, thump, long pauses between beats. This is fine, this is healthy, this is deep relaxation, approaching sleep, the body conserving, resting, preparing for dreams or nothing, just void. If a white dwarf accretes enough, reaching the Chandrasekhar limit, 1.4 solar masses, electron degeneracy can't hold, carbon fusion ignites throughout the star simultaneously. Runaway thermonuclear supernova type I, brightness always roughly the same, making them standard candles, revealing cosmic distances, accelerating expansion, dark energy, the universe growing faster and faster into cold, dark infinity. But here, now, in this room, there's only warmth, softness, you and the darkness. Nothing expanding, nothing changing, just stillness, perfect, complete, eternal. Now, Doppler spectroscopy reveals hidden planets. The star wobbles, pulled by orbiting planet. Spectrum shifts, blue, approaching, red, receding, periodic, revealing orbital period, mass, distance. From starlight alone, we know invisible worlds circling distant suns. Thousands found this way, thousands more waiting, undetected in the data, in the darkness between stars. Some binary stars eclipse from our viewpoint. One passes in front of the other. Light dims precisely, predictably. From the light curve, we learn stellar sizes, temperatures, orbital inclination, separation, everything from watching brightness rise and fall. Information encoded in light, decoded by careful observation, patient measurement. Your observation is ending now. No more watching, no more measuring, just experiencing, or not even that, just being, fading, dissolving into the background like light, red-shifted by cosmic expansion, stretched, thinned, approaching invisibility. First stars, population D3, massive, metal-free, burning, fierce and fast, dying as pair instability supernovae, completely destroyed. No remnant, just expanding debris, seeding space with the first carbon, first oxygen, first iron, making possible everything after. Every complexity, every planet, every life owes existence to those first stars, unknown, unmourned, but foundational. Dark ages, before first stars, the universe, cooling, expanding, neutral hydrogen, opaque, dark, no light sources except fading cosmic microwave background. For hundreds of millions of years, darkness. Then, first stars ignited, their light, ionized surroundings, creating bubbles of transparency. These bubbles grew, merged, eventually re-ionizing the entire universe. Cosmic dawn, light, returning, but different light, starlight, scattered by new structures, new complexities. We can't see those first stars, too distant, too faint, red-shifted, beyond visibility, but we see their effects in galaxy formation, in cosmic microwave background polarization, in the chemistry of ancient stars, evidence, indirect but compelling. They were there. They changed everything. Then they died. And only their legacy remains. Legacy. What will yours be? Does it matter? In cosmic terms? No. In human terms? Perhaps. But right now, in sleep, even that doesn't matter. Let go of legacy, of meaning, of importance. You're just atoms, temporarily organized, soon to disperse, like stellar wind, like planetary nebulum, beautiful, brief, returning us to the medium from which you came, globular clusters, ancient, beautiful, perfect sphere of stars, hundreds of thousands, all born together 10 billion years ago. They orbit through the galactic halo, unchanged, preserving the early universe's conditions, low metallicity, old stellar populations, evolutionary stages, visible from main sequence to red giants to white dwarfs, a snapshot of stellar life, frozen in time, in their cores. Stars pass close, interact, form binaries, collide, merge, blue stragglers, formed through collision or merger, appear younger than possible. They've been rejuvenated, refreshed by cosmic violence, hidden beneath normal spectra, normal behavior, a secret, written in motion, in position, in mass. Your secrets are safe. No one needs to know. In sleep, there are no secrets, no truth, no lies, just experience without judgment, without meaning. Thoughts bubbling up, sinking down, neither true nor false, just phenomena passing through awareness or through nothing. Open clusters, younger, looser, Pleiades, Hyades, beehive, born together, hundreds of stars from one nebula, but gravity weak, tidal forces from the galaxy slowly dispersing them. Over millions of years, they spread, losing members, eventually completely dissolved. Stars scattered, their sibling relationship forgotten, unknowable. The sun probably had siblings, born in a cluster 4 billion years ago, now lost, anonymous among billions, never to be identified, never to be reunited. Separation is inevitable. Nothing lasts, nothing holds together forever. Let that comfort you. Nothing lasts means nothing matters, means you can release everything. All burdens, temporary, all joy, fleeting, all pain, passing. Just let the current carry you. No resistance, no effort, floating downstream toward sleep, toward dreams, toward nothing. Stars near. Sagittarius A, the galactic center's black hole, orbit in elliptical paths. S2 circles in 16 years, closest approach 17 light hours from the event horizon, moving at 5,000 kilometers per second, 3% light speed, time dilation, measurable, general relativity, tested, proven, gravity, warping space-time, slowing clocks, bending light, beautiful mathematics, made visible in stellar motion. At that speed, time passes slightly slower for est than for us. The difference, tiny but real, relativistic effects, the universe, stranger than intuition suggests, space, time, mass, energy, all interconnected, all flexible, all relative, like consciousness. Flexible, relative, slipping between states, waking, dreaming, sleeping, without clear boundaries, just gradients, transitions, fading. R136A1, most massive star known, 300 solar masses, shining with 5 million solar luminosities, wind so strong it loses a solar mass every few million years, cannot last, already shrinking. When it explodes, it will outshine the full moon, briefly visible in daylight, for weeks, then fading, leaving a black hole, perhaps 100 solar masses, the most massive stellar remnant possible, darkness, born from ultimate light. Smallest stars, EBLM Jafar 57 Abe, barely massive enough for fusion, 8%, solar mass, smaller, and it would be a brown dwarf, failed star, glowing only from contraction, but it made it barely, fusion ignited, burning slowly, efficiently, for trillions of years. It will outlive everything, last ember in a cold universe, still shining when galaxies have gone dark. You will not outlive even this night. Your consciousness, temporary, fragile, already fading, but that's okay. That's perfect. You don't need permanence. You just need this moment, and then release. Let it go. Let it all go. HD 142 3 14 billion years old, nearly as old as the universe. Metal poor, ancient, population 2, born in early galaxy, survivor, witness to cosmic history. What has it seen? The formation of galaxies, births of billions of stars, deaths, supernovae, but stars don't see, don't remember. They simply exist, shine, and die. No awareness, no experience, just physics, playing out inevitably. Be like that. No awareness, no experience, just physics, breathing, automatic, heart beating, unconscious, brain activity, slowing, delta waves, rising, sleep, approaching, unstoppable. Let it come, welcome it, surrender to the inevitable, the natural, the necessary. In the far future, trillions of years hence, the last red dwarfs will finally exhaust their fuel, the stellar era ending, no more stars, no more fusion, only white dwarfs, neutron stars, black holes, and darkness. The black holes will evaporate through Hawking radiation, taking Google years, but inevitable. Eventually, even they will fade. The universe approaching heat death, maximum entropy. No more change, no more time, no more meaning, just uniform darkness forever. But that's so far, unimaginably far. Right now, stars still shine, life still exists, you still breathe, even if barely, even if fading, still here, still existing for a few more moments before sleep takes you completely. The stars keep burning while you drift deeper. They don't need your attention. They were shining before you were born. They'll shine after you're gone, indifferent, eternal, beautiful. Let them keep watch while you let go, trusting the universe to continue without your participation, your observation, not required, your consciousness not necessary. Just release into darkness, into silence, into sleep. Stars breathing light into darkness, creating heavy elements, enabling planets, life, consciousness, just so consciousness can look up, wonder, and eventually return to sleep, the universe creating witnesses to itself, then letting them rest. Eternal cycle of waking and sleeping, knowing and forgetting, being and not being. Your being is fading, now almost gone, just echoes of awareness, distant, unimportant, like starlight from the edge of the observable universe, redshifted, stretched, dimmed, almost invisible, almost nothing. And in that nothing, peace. In that absence, rest. In that darkness, home. Let the stars keep shining. Let the universe keep turning. Let yourself finally, completely let go. The universe keeps turning while the stars keep breathing light into the dark, and will keep drifting, floating together through the mysteries.